All right, today we're going to put on our detective hats. We're here to solve one of the most common and, frankly, most frustrating mysteries in tech: why a super successful app can suddenly grind to a halt. So picture this. You've done it. Your app, your service, whatever it is, it's a smash hit. Users are flocking to it, the numbers are going up and to the right. But then, the dreaded complaints start rolling in. It's slow, it's lagging, it keeps timing out. What in the world is going on? Well, the prime suspect is almost always the same. Your success is literally overwhelming your database. It just can't keep up. But don't you worry. We're going to follow the clues, piece together the evidence, and crack this case together. So let's get started. First up, let's just set the scene and really get our heads around this weird paradox of growth. Okay, so our crime scene is a classic one, a read-heavy API. What does that mean? Well, think of a news site, a social media feed, maybe a product catalog. It's a place where tons of people are looking at data, but not a lot of people are actually changing it. And as your traffic grows, the time it takes to fetch that data just gets longer and longer and longer. And trust me, your users are noticing. That's our problem. Now, any good detective will tell you you never, ever jump to conclusions. You need evidence first. So it's time to follow the clues. Before we even think about changing a single line of code, we got to look at our dashboard. What are the vitals telling us? Is the CPU just totally pegged at 100%? Because that usually screams inefficient queries. Are we running out of memory? Or maybe we're hitting our disk input-output limit, what we call IOPS. Are we just running out of connections? These right here, these are the fingerprints the culprit always leaves behind. And that brings us to what is, honestly, the most critical piece of evidence you will find: this slow query log. This thing tells you exactly which database operations are taking forever to run. It's not just a clue, it's practically a confession written down. Every single investigation should start right here. Okay, with our evidence in hand, we can finally go and confront the most common offender in these database slowdowns. And the solution, more often than not, is an index. So what is that? Well, the best analogy I've ever heard is the index at the back of a textbook. Instead of flipping through every single page to find a topic, you just go to the index, find the topic, and it tells you exactly which page to turn to. A database index does the exact same thing for your data. Simple as that. And the difference it makes, it is just night and day. Without an index, the database has to do what's called a full table scan. It's literally reading every single row to find what it's looking for. But with an index, boom, it performs a direct index seek. It's the difference between reading an entire encyclopedia and just looking up a word in a dictionary. The impact on speed and your CPU usage is absolutely massive. But what if you've optimized your queries? You've added all the right indexes, but the sheer volume of traffic is still just too much. Well, then it's time to call for backup. And that backup is the read replica. Think of your main or primary database as the head chef in a super busy kitchen. They're handling all the important new orders, the writes. A read replica is like a whole team of sous chefs who have a copy of the menu and can handle all the requests for existing dishes, the reads. They take all that pressure off the head chef. So this new workflow is really simple, but it is so powerful. Anytime your app needs to write new data or update something, it talks to the primary database. But when it just needs to read data, it can ask any one of your replicas. And the best part? You can just keep adding more and more replicas as your read traffic grows. And this is a really crucial point. This strategy absolutely shines in the exact scenario we're investigating, a read-heavy application. If you have 1,000 people reading data for every one person who's writing it, this pattern will fundamentally change your ability to scale. So we've optimized our queries and we've distributed our read traffic. Now, let's talk about the final boss of performance tuning. Let's talk about the secret weapon for getting those near-instant response times. And I'm talking about the caching layer. A cache is just a super fast in-memory data store that sits right between your application and your database. It's kind of like a server at a party, keeping a platter of the most popular appetizers right at the front so they don't have to run all the way back to the kitchen for every single order. And the impact here is just astounding. Going to your database takes milliseconds, which is fast, don't get me wrong, but going to an in-memory cache, that takes microseconds. That's 1,000 times faster. For your users, it just feels like pure magic. So here's how it works. When your app needs some data, it first checks the cache. Hey, you got this? If the data is there, we call that a cache hit. It gets it back instantly. Done. If it's not there, a cache miss. No big deal. It just goes to the database, gets the data, and here's the crucial part. It stores a copy in the cache for the next time it's needed. So you see, a cache delivers this awesome 1-2 punch. It makes your app feel incredibly snappy and responsive for your users, and it acts as a powerful shield for your database, protecting it from getting hammered with repetitive requests for the same popular data over and over again. Okay, so we solved our immediate problem. Case closed, right? Well, not quite. See, the best detectives don't just solve cases. They figure out how to prevent future crimes. So let's talk about building for success from day one. This right here, this is your playbook. It's a repeatable strategy for scaling. You always start with the data. Then you fix the low-hanging fruit with indexes. When volume itself becomes the problem, you scale out with replicas. And for that ultimate speed, you accelerate with a cache. And you have to remember, this is a cycle. You always monitor and you repeat. And this chart, it really just visualizes our whole detective story, doesn't it? We started with a crazy high load on our database. Indexing brought it down significantly. And then layering on read replicas and a cache just reduced the load to a tiny fraction of what it was, giving us massive headroom for future growth. And that, right there, is the key takeaway. Performance tuning isn't just about frantically putting out fires. It's about building a fireproof architecture. It's about designing a system that doesn't just handle the success you have today, but actually embraces the success you're planning for tomorrow. So I'll leave you with this question to think about for your own projects. Are you just keeping up, or are you building an architecture that's actually ready for your next big win?